So students, today we will see some important derivations of dipole. You are required to find electric field due to dipole. In that, first one is at an axial point, means the point will be on the axis of the dipole. So as you know, dipole consists of 2 point charges minus q and plus q. So dipole consists of 2 point charges minus q and plus q. So the distance between these two charges is 2a. So distance between these two charges is 2a. So O be the midpoint of this dipole. O is the midpoint of this dipole, means this length will be equal to A and this length will be equal to A. Dipole axis will be directed from negative to positive. Always dipole axis is from negative to positive. So along this line on the axis, I will take a point P at a distance r from center. So from center, this distance is equal to r, where r is very much greater than a. So this distance is very much greater than this 2a or a. We are required to find electric field due to these charges at point P. Now first, if I take this plus q, it is a positive charge, so its electric field will be directed away from positive. So let E1 be the electric field due to plus q. So E1 is directed in this direction. E1 is electric field due to plus q. Similarly, there is electric field due to minus q. As a charge is negative, it is directed towards minus. So it is directed towards negative. This I will take it as E2. So E1 is due to plus q, E2 is due to minus q. Now, first we will write expression for E1 and E2. So electric field formula is 1 by 4 pi epsilon naught q by r square. So electric field at point P due to charge plus q, E1, is given by E1 is equal to 1 by 4 pi epsilon naught, charge is q, divided by distance of plus q from P is distance from here to here, it is r minus a. From center to plus q is a. So distance of plus q from P is r minus a. So you will have divided by r minus a bracket square. So 1 by 4 pi epsilon naught q by r minus a bracket square. So E1 is directed along dipole axis. So here I will write along dipole axis. Along dipole axis. Now similarly, if you write expression for E2, E2 is due to minus q. So charge is again same. Distance changes. So minus q is at a distance of r plus a from P. Till here it is r. Then this is a. So distance of minus q from P will be r plus a. So E2 you will have, E2 is equal to 1 by 4 pi epsilon naught q divided by r plus a bracket square. R plus a bracket square. So now E2 is opposite to E1. So it is opposite to dipole axis. So opposite to dipole axis. Directed opposite to dipole axis. Now, resultant electric field at point P. So we will see resultant electric field at point P. Now in previous sessions we have seen these two electric field are acting in a same line but in opposite direction. If two vectors are in the same line but in opposite direction, then resultant will be difference of these two. So here it will be E1 minus E2. So resultant electric field, I will denote it by E. E is equal to E1 minus E2. E1 minus E2. So now I will substitute these values and simplify. Equal to E1 is 1 by 4 pi epsilon naught Q divided by R minus A bracket square minus E2 is 1 by 4 pi epsilon naught Q divided by R plus A bracket square. Now take common among these two. So simplifying, I will take a common Q and 1 by 4 pi epsilon naught. So Q divided by 4 pi epsilon naught common I will take. So remains is 1 by R minus A bracket square minus 1 by R plus A bracket square. R plus A bracket square. So up till here clear, students? So you can pause, note down these steps. Okay. So now further simplifying. If I simplify further, now here in this bracket I will take a LCM. So this is cross multiplied over here, this to the right side. Therefore I will be having E is equal to Q by 4 pi epsilon naught into bracket. If I cross multiply R plus A bracket square minus R minus A bracket square divided by R minus A bracket square into R plus A bracket square. R plus A bracket square. Now in numerator I will apply A square minus B square. Even you can take A plus B whole square and A minus B whole square. It will be easy to apply A square minus B square. So Q by 4 pi epsilon naught into bracket. If I take A plus B, it will be R plus A plus R minus A into another bracket A minus B, R plus A minus R plus A. If I take minus, this will be minus, A will be plus. So minus R plus A divided by. Here both these terms are bracket square. This is also square, this is also square. In school days you have studied A square B square can be written as AB bracket square. A square B square can be written as AB bracket square. Similarly I will write this. So this can be written as A square B square, A into B. So R minus A into R plus A bracket square. Bracket square. Now in the numerator, here A gets cancelled, plus A and minus A. You will have 2R. In the second bracket R gets cancelled, so you will be having 2A divided by. Now if you multiply these two, it is in the form of A square minus B square. So denominator will be R square minus A square bracket square. R square minus A square bracket square. Now combine this Q with 2A and R will be very much greater than A. R is very much greater than A, therefore A square is neglected. A square is neglected. As R is very much greater than A square is neglected. A square is neglected. So I will be having E is equal to 1 by 4 pi epsilon naught. I will combine this Q with 2A. So 2R 2A into Q divided by R square bracket square. We leave this A square. So again you can pause and note down these steps. Okay. So now here you remember this 2A into Q is P, that is dipole moment. So R square bracket square will be R raised to 4. So I will have E is equal to 1 by 4 pi epsilon naught 2R into P divided by R raised to 4, where P is equal to 2A into Q, dipole moment. Now here 1R gets cancelled and that is our final expression. So electric field E is equal to 1 by 4 pi epsilon naught, R gets cancelled, you will have 2P by R cube. So this is expression for electric field due to dipole at a point on dipole axis. Here you are required to write direction. Now while taking E, I had taken E1 minus E2, means E1 is greater than E2. So this will be in the direction of E1, or you can say it is along dipole axis. If he asked to write vector form of electric field, so vector form will be E vector is equal to 1 by 4 pi epsilon naught 2P by R cube into P cap. 2P by R cube into P cap, where P cap is unit vector along dipole axis. Clear, students? So you can again pause and note down these steps. Then we'll go for second derivation. Okay, students. Now we'll see second derivation. Electric field at a point on equatorial line of a dipole. So equatorial line means perpendicular bisector. So now again, a dipole consists of 2 point charges plus Q and minus Q. So minus Q and plus Q. The distance between these two is 2A. Dipole axis is always directed from negative to positive. O be the midpoint of this dipole. This point I will take it as A. This point I will take it as B. So this AO is A, OB is A. As O is midpoint of this dipole. Now if I take a perpendicular line over here passing through center O, this is nothing but our equatorial line, or you can say perpendicular bisector. So equatorial line. On this line, take a point P. A point P at a distance R. A point P at a distance R from O, or a dipole at a distance R from O. We are required to find expression for electric field at point P. We are required to find formula for E at P. Now again there will be electric field at P due to plus Q. As it is positive, electric field will be directed away from positive charge. So electric field will be directed away from positive charge. So in this direction we will be having E1. E1 is electric field due to plus Q. Similarly, there will be electric field due to minus Q, that will be directed towards minus Q, that is towards A. This I will take it as E2. E2 is electric field due to minus Q. E1 is electric field due to plus Q. Now, as this is 90, by Pythagoras theorem, I will be having this hypotenuse as root of r square plus a square by Pythagoras theorem. Now similarly, if you take this triangle, this is A, this is R, again here also hypotenuse will be root of r square plus a square. Means these two triangles are similar. I will take this angle as a theta. As the triangles are similar, this angle also will be equal to theta. Now draw a line, or I will take a line parallel to AB passing through P. A line parallel to AB passing through P. So these two lines are parallel. Therefore, if this angle is theta, this angle will also be equal to theta by alternate angles. This is theta, so this also will be theta by corresponding angles. Means these two angles are same. Now, I will resolve these two fields, E1 and E2. So, if I resolve E1 along horizontal, so horizontal component will be E1 cos theta. Horizontal component will be E1 cos theta. Vertical component will be E1 sin theta. Vertical component will be E1 sin theta. Now similarly, if I resolve E2, so horizontal component of E2 will be E2 cos theta, and vertical component of E2, it will be acting downwards, E2 sin theta. E2 sin theta. So figure is clear, students. So there is a dipole. P is a point on equatorial line at a distance R. R is very much greater than A. E1 will be acting along BP. E2 will be acting along PA. So if we resolve E1 cos theta, E1 sin theta, similarly E2 cos theta, E2 sin theta. Now I will write expression for E1. So I will write expression for E1. E1 is electric field due to plus Q. So by formula 1 by 4 pi epsilon naught. So 1 by 4 pi epsilon naught Q divided by. Distance is from here to here, BP, that is this. So square of this will mean root gets cancelled. So Q by R square plus A square. 1 by 4 pi epsilon naught Q by root of R square plus A square. It will be directed along BP. So direction along BP. Similarly, if I write expression for E2, charge is same, distance BP will be also same. So E2 you will have same expression, only direction changes. Direction is along PA. Direction of E2 is along PA. So E2 is equal to 1 by 4 pi epsilon naught Q by R square plus A square along along PA. So along PA. Now if you observe here, magnitude of both these E1 and E2 is same, only direction changes. So I can say therefore E1 is equal to E2 only magnitude. Only magnitude. Magnitude of both vectors are same. Now if you observe the figure, E1 sin theta and E2 sin theta are in the same line but in opposite direction. So if two vectors are in the same line in opposite direction means we take difference of these two. But as E1 is equal to E2, theta is the same, means these two are same. So resultant of these two will be 0 or they get cancelled. So I can say E1 sin theta and E2 sin theta gets cancelled. E2 sin theta gets cancelled. Gets cancelled because both are equal and opposite. Now E1 cos theta and E2 cos theta both are also in the same line but in the same direction towards left. This is opposite to dipole axis. So they are in the same direction means they get added. So resultant field at point P will be E1 cos theta plus E2 cos theta. These two get cancelled. So resultant electric field at point P E is equal to E1 cos theta plus E2 cos theta. E2 cos theta. Now E1 is equal to E2 means both these two terms are same or equal. So I can add those. So you will have 2E1 cos theta. 2E1 cos theta. Now I will substitute value of E1 and cos theta. So now I will substitute the values. So therefore E is equal to 2. Even if I substitute 1 by 4 pi epsilon naught q by r square plus a square into cos theta is from the figure. Cos theta is adjacent by hypotenuse. So cos theta is a by root of r square plus a square. So into a by root of r square plus a square. Root of r square plus a square. Now I will multiply all the terms in the numerator. So I will be having 1 by 4 pi epsilon naught 2a into q. 2a into q. This is as it is r square plus a square bracket raised to 1 I will write to understand for the students. Now root I will write it as r square plus a square raised to 1 by 2. R square plus a square raised to 1 by 2. Now numerator this you know 2a into q is p, very good. Now if you observe denominator, base is the same, so I can add power. Therefore it will be r square plus a square raised to 3 by 2. So you will have 1 by 4 pi epsilon naught p divided by r square plus a square raised to 3 by 2. R square plus a square raised to 3 by 2, where p is equal to again 2a into q. While drawing diagram I told that r will be very much greater than a. So again here a square is neglected. So as r is very much greater than a square is neglected. a square is neglected. So I will now leave this a square. So if I simplify further, so you can pause and note down this step, student. If I simplify further, I will be having E is equal to, so we have E is equal to 1 by 4 pi epsilon naught P, a square is neglected, r square raised to 3 by 2. So this 2 gets cancelled. So final expression is E is equal to 1 by 4 pi epsilon naught P by r cube. This is expression for electric field. Expression for electric field. So along the axis you had 2p, along the equatorial line you will have p. Then again you are required to write a direction. Direction you are required to write. So resultant will be along left, that is parallel and opposite to dipole axis. So direction parallel and opposite to dipole axis. Parallel and opposite to dipole axis. For 1 marks, if we ask vector form, again E, arrow mark, you will have 1 by 4 pi epsilon naught P divided by r cube into p cap, where p cap is unit vector along the dipole axis. Now here you should take care, students. Direction is opposite to dipole axis while P is along the dipole axis. So here you should write minus. Here you should write minus. So minus indicates opposite to dipole axis. So E will be opposite to dipole axis. So you can pause and note down the